Hi guys, in this tutorial I am going to show you about the number system. You know, there are eight type of number system. Basically, the number system is four types. Or one is decimal number system. Decimal number system means the real number system or decimal number consisting of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means decimal number containing 10 numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means the element of decimal number is the number of decimal number is 10. So that's mean again I count 1 2 3 4 5 6 7 8 9 10 or 10 numbers. So the here is 10 numbers, so the base of decimal number is 10. So the base of decimal number is 10 and decimal number consists of these numbers system. Okay, now the next is binary numbers. Binary number is consisting of 0 and 1. Here 0 is means the low and 1 means high. Here is only used two numbers or two digit, that means 0 and 1. So 0 means low and 1 means high, so hence here is two digit, so the base of binary number is 2. Okay, and the next number system is octal number system. The octal number we use 0, 1, 2, 3, 4, 5, 6 and 7. Here is 1 2 3 4 5 6 7 8, or here is 8 digit. So the base of octal is 8, right? And the next number system is hexadecimal. Hexadecimal number the digit is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E and F. A means 10, B means 11, C means 12 and 13 and 14 and 15. Okay, here is the number digit number is 1 2 3 4 5 6 7 8 9 10 11 12 13 14, sorry, 10 13 14 13, sorry, 10 11 12 13, sorry, 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. So here is digit is 16 digit, so the base of hexadecimal number is 16. Okay, right? And the another number system is ASCII value. ASCII means American standard code. ASCII means American Standard Code. And the BCD numbers is means binary coded to decimal, that means binary equivalent to decimal numbers. And the another number is ones complement. Ones complements is only is the binary number systems. That means if we write a decimal number 4, then the binary number of the equivalent number of binary is 0 1 0 0. So if we give is ones complement, then if each digit is reverse 0, if 0 then 1, and if 1 then 0, then here is 0 then 1, here is 1 then 0, here is 0 then 1, and here 0 and 1. This is an ones complements of the binary numbers. And here is also the twos complement. Twos complement means extra 1 is add with ones complement. So this is twos complement. So how to revert is to twos complement. Then if the decimal number is 4, then the binary number is 0 1 0 0, and the ones complement is 1 0 1 1 and add 1. So 1 on 0 1 on 0, you know the binary addition, and 1 1. This is the twos complement. This is the twos complement. Okay, and the shortcut technique of twos complement is, if we 4, the binary of 4 is 1 0, sorry, the binary of 1 0, 4 is 1 0 0, and the ones complement and the shortcut technique of the twos complement of every number is, when we start right side, that means 0 0. When we take 1, then we write 1, and then 0 1 and 1 0. 1 will be 0 and 0 will be 1. Here is 0 then 1. So this is the twos complement. I repeat again the shortcut technique of twos complement. We are start right side, that means if we at first 1, then write 1, and the other digit reverse 0. If 0 then 1, and if 1 then 0. Here is 0 0 0 0. Here we take 1, so write 1 and then reverse the next digit, that means 0 1. If here is another 1 0, then 0 is 1. If here is 1, then here is 0. So this twos complement is here. So this is the technique, shortcut technique of twos complement. Thanks for watching my video.